Problem 13.151 has a 75-gram ball projected horizontally with a speed of 2 meters per second at about 1.6 meters above this plate right here. And it bounces off the plate. The plate has a mass of 400 grams, and it bounces back to a maximum height of 0.6 meters. The plate's smooth, so there's no frictional forces along the horizontal direction there. Um, wants us to determine the velocity of the plate immediately after the impact. So we're going to use conservation of energy, which is T1 plus V1 equal T2 plus V2. And that's going to be used to determine what the velocity is coming down vertically here. So you have 1/2 m Vx naught squared at the top. There is no velocity in the y direction. Plus your potential energy is mgh1 because we're setting potential energy equals 0 at this level right here. And that's equal to 1/2 m. The velocity squared down here would be Vx naught squared plus Vy squared because you have picked up a Vy. And then you have 0. Now you'll notice that the Vx naughts here, squared terms will go away, and you'll end up with Vy being equal to square root of 2gh1. We choose the negative sign in front of the radical there because it is downward velocity. Now we're going to use conservation of momentum next, and we're going to do that this because we can spring force and the gravitational force are non-impulsive. And so we basically have a system of ball and plate without any external forces acting on that. And that's why we can conserve momentum in the y direction. So we have the ball coming in with m times Vy plus the velocity of the plate 0. The final velocity after the contact is made, we're going to call the final velocity of the ball as a Vy prime. And then, so m times Vy prime is this momentum. And then the momentum of the plate is capital M times velocity of the plate. This is similar to the above, so Vy prime is going to be square root 2gh2. The same way we got the 2gh1 for the velocity coming down, the velocity going up then is going to be square root 2gh2. We choose a plus sign because that velocity is going upward. So if you solve a Vp out of this, you'll find that you end up with this expression right here of the mvy, well, the m is in both terms right here. So it's Vy minus Vy prime. Vy, though, is negative square root 2gh1, and Vy prime then with a negative sign because it comes over the other side is negative square root 2gh2. And then we add to a capital M. When you do that, you'll get the velocity of the plate is negative 1.694 meters per second. And they want us to, in the C part, to find the energy lost due to the impact. I'm just going to calculate the change in energy that took place. A change in anything is the final, which I'm going to call E prime, minus the initial, which I'm going to call E. The final energy just after impact is 1/2 m Vx naught squared plus Vy prime squared for the little mass m. And then the kinetic energy of the plate is 1/2 times capital M times V velocity of the plate squared. And then we're going to subtract the initial energy, and the initial energy is only the energy of the ball coming in, which is has a Vx naught squared plus Vy squared. Now I realize that you could have done this without the Vx naught, but you know, this is an energy expression, not a vector expression, so you have to get the x and y components both in there, even though that term is going to subtract out against that term right there. So what we're left with to calculate this is we have 1/2 m Vy prime squared. The Vy prime is given by square root 2gh2. So what we get out of this then is just the mgh2. And then this term right here is 1/2 m Vp squared. And then this term right here, the x naught term goes away with that one. And so we have a Vy, which is square root 2gh1, and then times 2m comes just minus mgh1 then. And so when you plug all your numbers in, you get a negative 0.1619 joules. The negative sign shows that that the change is negative, which means that's the energy loss then.